Hi, welcome back to the Food Forest. It's been a little bit since the last video because we're getting near the winter equinox, and when I get home from work, it's pitch black outside. I'm actually home during the day today, so I can squeeze a video out before the sun sets. So if you're wondering where I've been, I'm all right. It's just when you get home and it's pitch black, it's impossible to do YouTube content. So I've had a lot of time to think about what I wanted my next video to be, and I really want to give back in terms of my engineering expertise and combining that with permaculture stuff. And I thought a perfect way to do that is to talk about heat. So we're gonna do a heat video today. Now this topic is actually so deep that I could probably do like 3 hours on it. So I'm gonna try to cover as much as I can. I'm not gonna be able to cover absolutely everything. But one of the reasons why I did also want to cover this is that there's a lot of these, it's kind of like a new fad to have these little plug-in space heaters, and there's a lot of claims that are made by these tiny little plug-in space heaters that I would consider actually on the scam category. So we'll get into that as well when we talk about space heating. But first, I want to talk about what heat is. So heat is nothing more than a measurement of the velocity of atoms in the atmosphere hitting against your skin. It's what we feel, and we're actually feeling the kinetic energy of the particles that are hitting us. That's what heat is. So when we're talking about heating up a space, we're talking about just making the molecules in the environment move around a little faster. That's it. Now in about grade 10, we learn one of the basic heat formulas, which is Q equals mc delta T. And Q is the heat flow, and it equals the mass of the thing that is having a thermal gradient across it, which is the delta T part. And then C is basically just how well that medium will conduct heat from one thing to another. So when we're talking about the flow of energy, the flow of heat, what we're really interested in is that temperature gradient. So for your house, that means that the colder it is outside, right where you have stuff like windows or walls, we really want to insulate them. The last way we lose our heat is just from a direct flow of that indoor atmosphere that's moving around a lot to the outside. That happens from density gradients, and it happens from heat gradients. So if you've got a lot of leakage, if you have a window that's wide open, or you have leakage in and around doorways and all that, then you're going to lose that heat environment outside. Everyone, is kind of common sense. Most people know that kind of thing, but that's what we're talking about when we're talking about heating a space. You've got a little black box. You're going to get heat coming in from whatever method you're going to use to heat, and then you're going to have heat going out, and that's basically your leakage and your loss. That loss is also sometimes called the heat load, and that is basically the work that some kind of heating device has to pump in just to offset that. And where you have them both equal, then you've got no change in heat anymore. So thanks for sticking with me through that. I know some people who may already know that stuff might have found that a little boring, but some people don't know that stuff. So it's really important that we describe that, because it's important now when we're going to talk about space heaters. So let me show you a little space heater unit here. So I'm not affiliated with this brand or anything. I'm not recommending that you buy this or anything, but I just wanted to show you kind of what a space heater might look like. And I want to talk about space heaters specifically because for the most part, it actually really doesn't matter what kind of space heater you get. So let me talk about that and why that actually is the case. Okay, now this one here is an infrared heater, and there's basically going to be two types of heat. There's going to be infrared heat that's going to heat things with electromagnetic waves, basically infrared waves. And there's also space heaters that are going to heat things up by heating some kind of element inside the heater and then blowing that heat out mechanically using some kind of a fan. Okay, a heater that's actually going to have a hot element inside of it and then it's going to blow that out. What that's actually doing is it's heating up the molecules in and around that element, and then it's blowing that energy out. And as those molecules bounce off of other molecules, they'll transfer their heat to the other thing. This is a real direct way of heating, and when you're heating this way, you're actually heating the entire room up. With an infrared heater, it's a little bit different. Infrared heaters will actually just send electromagnetic waves, which is basically the whole visible spectrum, ultraviolet all the way up to infrared. They focus on the infrared because it's lower energy, it's longer wavelengths, and it's not going to give you cancer. For example, they could heat you pretty quick with ultraviolet light, but that probably wouldn't be very good for a sales pitch, because you're actually going to be killing your customers. They use infrared because it's low energy electromagnetic spectrum, and also because the human body actually tends to just absorb that heat as well. Because it's low energy, we just absorb it, and it actually directly heats us. So what that means is if you have an infrared heater at one side of the room and it's pointing at you and it's hitting you, it's actually hitting and warming yourself up. It's not really doing a whole lot of full room heating. Now, as you heat up, then you will black body radiate out heat to the rest of the room, and wherever that infrared hits, if it's hitting a couch or it's hitting a wall, that will heat up slightly, and then that will kind of radiate heat out to the room. So you are going to heat the room up. It's going to happen slower though. Now, these infrared heaters can actually be really useful if you want to actually just, keep yourself warm. You're not necessarily worried about heating up your whole house. You're not worried about heating up the whole room. You're just worried about heating up the thing that the infrared heater is pointed at. Now, these can actually save you money, but the rationale is that if you're comfortable in a colder house, then your furnace isn't going to be heating the entire house. You can just heat yourself, and that way you save money that way. But if you're just trying to heat your entire house or that room, then an infrared heater and an electric filament heater, for example, are going to be exactly as efficient as each other. So let me explain why. When we're talking about another type of a machine, like a pump or an engine, then what matters is the energy that goes into it, and then the work that you get out of it, and how those two things compare, the ratio between those two things. Any loss from power transmitted versus power consumed is basically where the efficiency is lost. In machines, it's typically lost through friction, either a machine moving through air, or pieces grinding and rubbing up against each other, or just energy lost through heat from like a combustion explosion, where not all of the power is delivered. Some of the power is actually delivered to heating the stuff where the explosion is happening, for example. In all of these situations, the heat is actually the waste product. In a heating application, the heat is actually the goal. That's what we're trying to do. So when we have an electric element heater, we're actually taking electricity in and we're wasting it all. We're wasting all of it. So it's 100% efficient because it's all being wasted. It's being wasted as heat because that's the purpose of the device. This is the exact reason why, if you are buying a space heater and the goal is to heat the room up, then it doesn't matter at all about the technology or anything. They're all going to be as efficient as each other, 100% efficient, because they're all just a giant garbage factory of energy. The only thing that matters in a space heating application is the wattage, not the technology, not anything. It's the wattage. And it's very interesting that almost every single space heater on the market is at exactly 1500 watts. Why is that? It just so happens that 1500 watts is, by the electrical code, the most amount of power that you can pull out of a wall and have it be safe still. So every single electric heater device that's made for 120 volt circuits will all push right up to the electrical code, and they will all emit 1500 watts of power. Doesn't matter if you go to the store and look at every single unit and look at the specs, every single one will be 1500 watts. And the interesting thing is, some will say that they're for small rooms, some will say that they're for big rooms, and it literally does not matter. It's putting out 1500 watts. That's how much it's heating. Every single one of them is the exact same. Now, when I say that efficiency doesn't matter in heating applications, I'm talking about electric heating applications. If you have, say, a furnace, like a gas furnace, as soon as you're burning something, as soon as you're burning natural gas or propane, then efficiency can matter. For example, a condensing furnace can be more efficient than a regular furnace. What I'm talking about here is electric space heating, so turning electricity into heat via heat waste. Okay, so what does that mean for these little plug-in ones? There's a couple plug-in ones. I don't want to bash any company's names, but there's a lot of claims that are made that you can put in this tiny little 350 watt plug-in electrical space heater, and it'll do the same as these big other units, but they're, you know, $30 instead of $90. It's actually 100% false, because again, the only thing that matters is the wattage on the actual device. So something that's 350 watts is going to produce, you know, roughly a fifth of the actual heat as a larger heater. It's just, that's just the science. That's how it works. So if you're seeing any kind of commercial or advertisements for these little space in plug heaters, keep in mind that's great for heating up a small bathroom or a closet. It's not going to really work or do anything noticeable for a larger room, unless your house is very, very tight and you don't care about how fast that it heats up. Once it gets to that heat, then if you have almost no heat load, almost no heat loss, same kind of idea, same word, then that heater can offset that and keep the room warm. But if you got a cold room and you plug that thing in, you know, you're going to be waiting 5 times as long until you get a warmed up room than any other space heater. One other thing that actually might be nicer about an infrared heater that has nothing to do with heating is that if you have some kind of allergies or sensitivities to particulates being blown about the room, then if you're heating via infrared, then you don't have this giant fan that's circulating the air, and that actually might be easier for people who have allergies. So that's space heaters. I didn't want to really focus on that at the beginning because there's a lot of misinformation out there, and you know, I can kind of help as an engineer push through some of that misinformation and hopefully save you buying something that's just not going to work. Okay, so let's talk the permaculture side of all of this. Is an electric space heater good for you, for your application? If you have a large family and a large house and people are moving around between rooms, it's probably not the best use. If your electric grid is a dirty grid that runs on coal, oil, and gas, then it's probably not the best use, because that electricity is coming from burning coal, which is then converted to waste heat. So that's a really stupid way. I mean, you would be better off just, like, in terms of the closed loop of the environmental impact, you'd be better off just directly burning the coal in your living room. You know, obviously not for health reasons, but you'd be better off doing that in terms of the planet, because at least you're not transmitting the energy and getting the losses through, you know, I²R losses through the grid. If you're like me and actually have a fairly clean grid, Ontario, Canada has got one of the greenest grids in the world. So environmentally, for someone in Canada, if you can run off some kind of electric heating, it's really good for the environment, especially if that energy is coming from nuclear. That is as low carbon as you can pretty much get. And that's one of the reasons why we actually use a space heater in some applications in our house. When we know that we're going to be kind of staying in one room for a while, I'll crank the heat down and we'll just run the space heater. I usually have the house pretty cold as it is. I definitely believe in gearing up and wearing warm clothes in the wintertime, and I keep my pipes from freezing, but we don't heat a whole lot more than that. Now, right now in Canada, with the carbon tax out there, there's a lot of, you know, especially out east, there's a lot of clamoring about how that's impacting people who are heating their homes with oil. Now, oil is mostly used in areas of Canada or the world where you're both remote, so you can't get natural gas piped in. That way you have a tank of oil at the side of your house, and then you're burning that. Unfortunately, it's absolutely awful for the environment. It's awful for climate change. We're already looking like we're going to blow past 1.5 degrees, which is when some really nasty tipping points happen. And if we continue this way, we're going to probably look at roughly 2.5 degrees. And, you know, around 3 degrees is kind of like human extinction in the next 100 years or so. So we really do need to solve this. I know that it's really painful for people who are heating with oil. But if you can kind of lobby governments to installing things like small modular reactors and pushing that technology forward, then we can heat more homes with stuff like efficient space heaters run off of nuclear power. So regardless of what you think about the carbon tax, you know, I'm not a huge fan of it, but I understand that we have to do something. But I know that a lot of people who are, especially if you're out east and you're heating your homes with oil, it's really hitting you hard, and people have to heat their homes to survive. So I don't really like taxing things where we are pushing people, we have to survive, when the government's really not helping in other ways. So transportation's a little different. Government can help by building mass transportation, that kind of thing. I like the idea of carbon tax on those things more than carbon tax on heating for homes, which is necessity for survival for a lot of people. So other ways to heat your home, you've got stuff like a furnace, like a natural gas furnace, propane furnace, any of these things, they're burning carbon. Burning natural gas is probably the best way to actually heat your home outside of, if you're burning any kind of these fossil fuels. Burning natural gas is probably the best way. It depends on your area. You definitely look more into it. Natural gas is a byproduct of the other things that we're pulling out, the coal, oil, and gas. Whether or not we use the natural gas, that is coming out in each barrel of oil anyways. So as long as natural gas isn't the thing that we're going to mine the oil for, then it's actually not really that much of an increased extraction of oil in the economy. It's kind of more like it's kind of more like using a byproduct of our current oil hungry economy, but using it for the smartest way we could use it, which actually is for heating homes. So because of that, even though I am very much against coal, oil, and gas, I do think that natural gas used as heating is probably the best use of natural gas in our current economy, especially if we're gonna be extracting coal, oil, and gas anyways, and it's more of a byproduct. With the caveat that we need to come off of this, we need to start designing in better solutions in order to move forward, because the end of oil is coming, like no matter what, it's coming. So we need to understand that we're using them temporarily to transition into something better. Now, probably the best way to heat your home is geothermal with like a heat pump, especially if you're heat exchanging through a pond that's outside. You can get extremely efficient heat exchange in this way. The biggest downside is that it's quite expensive to get it actually set up. Now, there's two ways to do the heat exchange outside, pretty much horizontally or vertically. Either you drill straight down and you do kind of like a big loop and exchange directly just with the Earth's core temperature, or you do it more horizontally, typically run around something with a lot of thermal mass like a pond. Now, geothermal itself is probably a 2-hour rabbit hole that we can jump down. So I'm going to leave it there because a lot of people watching this are going to be looking for ways they can retrofit or change the way that they are doing their heating. Retrofitting in a geothermal system can be really expensive. It's ideally something that you get going the day that you buy your property or develop. So I'll leave it at that for now, but absolutely the most efficient thing that you can do is a geothermal heating. The last way to heat the home, and one that I usually talk about first, especially to a permaculture audience, is burning wood. So burning wood is a great way to heat your home, provided a few things. So heating wood can be the single worst way to heat your home if you're putting wood in a open fireplace and burning that heat and throwing it straight up the chimney. It's probably one of the most disgustingly wasteful things that I can think that humans do with heat. And it makes sense because you have this giant fire and it's just going up a brick chimney and straight out the roof. Most of the heat, like I think is somewhere around 70% of the heat, actually just goes straight out your house. It doesn't do anything for you. And then we're burning all that wood, creating all that pollution, and cutting down environments and habitat in order to provide heat. It's just so extremely wasteful, it almost makes me sick. And I think when you see where we are as a society and as a civilization, the fact that a lot of people do that, it's mind-boggling. It's as mind-boggling as how normalized urinating in water, pumping water, filtering it, cleaning it, and then urinating in perfectly clean water, and then pulling the urine out in a water treatment plant, when basically we could walk anywhere and urinate, and it's actually like a soil amendment. So we're taking something that's beneficial and then we're doing this absurd thing to one of the most precious resources, water, with our waste product. I think that's probably the most absurd thing that's normalized in society. I think heating your home in a fireplace is the second. Now, that being said, there are so many ways where we can take that ridiculous setup and make it actually pretty good. So if you are, instead of sending that heat straight up the chimney, if you are winding that through a thermal mass to store and hold the heat, and then have that thermal mass radiate heat outwards into your house slowly over time, and then you're releasing a very low load of heat to the atmosphere and the environment, that is fantastic. What I'm talking about here obviously is a rocket mass heater stove. Now, I don't have a rocket mass heater stove specifically because it is not allowed by code in any of the houses. So I could heat an outdoor space with a rocket mass heater stove. The amount of work that it takes to make a rocket mass heater stove, you know, it would probably take me between 6 months and a year to actually make it slowly, you know, after work, plus getting all the materials and all of that stuff. I've thought about doing it because, you know, I wanted to do it even just like as it'd be a really good video for permaculture, but it just makes no sense at all in my application here way north in Canada. And I could only use it to heat an outdoor space. So if I could heat an indoor space with it by code and I wouldn't, you know, invalidate my home insurance, then I would definitely do it. But if you can build a rocket mass heater and it's allowed in your area, then I would definitely look into it. The number one place to look is Paul Wheaton, but I'm also going to leave a link right here to a fantastic build and video series from another permaculturist who's just getting started in this. So check out this build video. It's fantastic if you're thinking about making a rocket mass heater. These things are amazing. The second way that you can improve burning wood to heat your house is if you're combining it with, say, cooking. So if you also have a cooking wood stove and then that's doubling as a heater for your house, then that is a fantastic use. The third way that you can really improve this equation is then if you're actually quenching the fire or burning it in an oxygen-starved environment and you're generating charcoal with it, which you then use as biochar to act as a soil amendment, so that at least roughly half to 2/3 of the carbon in the wood is actually getting returned back down into the soil. Then only about 1/3 of it gets released into the air. This is a way that we can also take heating our homes kind of to the next level, and where heating your homes with wood can actually start making a lot of sense. If you're then taking that carbon and you're building soil carbon with it as well, you're going to be releasing a little bit of carbon, but if the tree just falls in the forest and decomposes, it is also going to release some carbon, and it'll release about the same. A tree that fell and just decomposed naturally will release about the same amount of carbon as if you burn it in a charcoal furnace, get the heat out of it, but then take the charcoal because you quench it or you burn it in pyrolysis in an oxygen-starved environment. Check out my videos on biochar for more info on that. And then you take that charcoal and you put it back into the soil. Then that is actually, you know, in terms of the carbon footprint, that's basically about the same. It's probably actually a little better to actually run the biochar furnace as a heating for your home in terms of actual carbon releases. So don't let anyone tell you that burning wood for heat is wasteful and bad for the environment. It is 99% of the time, but it can be done really, really well. And it's one of the reasons why permaculture talks about using wood in things like a rocket mass heater. So thanks for watching this bit of a longer video on heat. If you have any questions, let me know in the comments below. Maybe I can direct the questions and funnel them towards a part 2 series where I answer questions on this, or maybe expand and elaborate on some of the topics that I discussed in this video. Last thing, if you got any value out of this video or any of my other videos and you want to support the channel, the best way to do it is through Patreon or the YouTube membership below. Patreon's a little better, the cut's a little smaller. But if you've gotten any use out of any of the things that I've ever told you, if you save some money on a space heater now, then, you know, I have the level set at as low as possible, like $1 a month. I figure I'd rather do that and have more people sign up than set them too high. So if $1 a month sounds like something you can manage, then consider supporting the channel. It does actually make a big difference when enough people do it. Right now, I'm making videos for less than minimum wage, and I'll be honest, I've thought it sometimes that my life would be a little simpler if I just simplified out the YouTube stuff. But if you did want to support, it does go a long way to making me think, hey, maybe I should keep doing this. And there's a lot of value, and people appreciate what's being put out there. So thanks for watching. I'll see you on the next video.